Ever stubbed your toe and without even thinking just grabbed it and started rubbing like crazy? Or, you walk into a door frame, whack your elbow, and your first instinct is to squeeze it? We all do it. It's this universal automatic reaction. But have you ever stopped and asked yourself why? Why does that actually make it feel better? It feels a little like magic, right? Well, it's not magic, it's science. So let's dive in and uncover the incredible biological hack our bodies have for shutting down pain. Okay, so this is it. This is the big question we're going to tackle. It seems so simple, but the answer is just fascinating, and it pulls back the curtain on this incredibly complex and honestly elegant wiring system that's running through our entire bodies. To really get the solution, though, we first have to understand the problem. So, before we can even talk about pain relief, we got to be clear on what pain actually is. And let me tell you, it is so much more than just a simple sensation, like feeling hot or cold. It's this whole complex experience. Now, this definition tells us two really key things. First, pain is both a sensory and an emotional experience. That's a huge deal. It's why pain can feel so completely overwhelming. And second, and this is crucial, pain is a protective measure. It's your body's alarm system, right? A big, loud warning bell designed to tell you, hey, danger, to prevent you from getting hurt even worse. It's actually the #1 reason people go see a doctor. And for good reason. It's a signal you really shouldn't ignore. So how does that alarm signal get from, let's say, your elbow all the way up to your brain? Well, it travels through your body's amazing internal wiring system, carried by these different types of nerve fibers. You can think of them like messengers, each one with a very specific job and, more importantly, a very different delivery speed. Let's meet our 3 main messengers, because the real secret here is speed. First up, you've got the A-beta fibers. These are the Formula One racers of your nervous system. They're big, they have this thick insulation called myelin, and they carry signals for touch and pressure at insane speeds, up to 60 meters per second. Then you've got the A-delta fibers. They're also insulated, and they carry that first sharp ouch kind of pain. They're fast, but not as fast as the A-betas. And finally, you have the C fibers. These guys have no insulation, and they are slow. They carry that dull, throbbing ache that kind of settles in after an injury. They're the slowest messengers by far. And trust me, this difference in speed, it's the key to everything. Okay, so you've got all these different signals racing toward the brain, but it's not just some chaotic free-for-all. Nope, there's actually a control system in place, kind of a checkpoint that gets to decide which messages get through. This brilliant idea is known as the pain gate control theory. So just imagine a gatekeeper standing guard in your spinal cord. This gatekeeper is actually a bundle of nerves. Its fancy name is the Substantia Gelatinosa of Rolandi, but we can just call it the SGR. Now, its job is to control the T cells, and the T cells are what actually forward the pain signals up to your brain. It's simple. If something stimulates the SGR gatekeeper, it shuts the gate. No pain signal gets through. But if it's not stimulated, the gate stays wide open, and that pain message gets sent loud and clear. And this is where it all clicks. So you whack your elbow. That slow, achy pain signal from the C fibers starts its long journey to the brain. But the second you start rubbing it, you create a brand new signal, a touch and pressure signal carried by those super fast A-beta fibers. That A-beta signal just blows past the slow pain signal. It wins the race to the spinal cord, gets to the SGR gatekeeper first, wakes it up and tells it to slam the gate shut, right in the face of the slower pain signal that's still trying to catch up. So what you're really doing is creating a competing sensation that is way, way faster than the pain. You're essentially creating a biological traffic jam. The fast touch message gets there first and blocks the road, so the slow pain message can't ever reach its destination in the brain. And if the signal never gets to your brain, you don't feel the pain. How cool is that? Mystery solved. Okay, so now that we know our bodies have this amazing built-in system, it kind of begs the question, right? Can we hack it? Can we use technology to intentionally slam that pain gate shut whenever we want? Well, the answer is a definite yes, and the technology is called TENS. TENS is short for Transcutaneous Electrical Nerve Stimulation. And what that really means is it's a device that sends tiny, totally safe electrical currents through your skin to get the attention of those sensory nerves. In other words, it's a way to artificially create those touch and pressure signals that we were just talking about without you having to rub anything at all. And here's where it gets really fascinating. TENS can actually hack our system in 2 completely different ways. On the left, you've got your high-frequency or conventional TENS. This zaps those super fast A-beta fibers, just like rubbing your elbow does. It closes the pain gate and you feel relief almost immediately. But then on the right, there's low-frequency TENS. This method uses a slower pulse to actually stimulate the slow pain fibers, the C fibers. Now you're probably thinking, wait, why would I want to do that? Well, because stimulating them in this way triggers a totally different system. It basically tells your brain to release its own all-natural painkillers, like endorphins. The relief takes a bit longer to kick in, but it can last a lot longer too.
So we've got this tech that can hijack our body's own pain-fighting systems. But who is it for? And what are the really important things you need to know before you even think about trying it? Let's get into the practical side of things.
TENS is actually incredibly versatile. It's used for a huge range of things, from a sudden injury to pain that's been around for years. It's also used a lot to help people manage pain after surgery, during childbirth, and even for those really tricky kinds of pain, like stump pain or phantom limb pain after an amputation. A big part of the appeal of TENS is pretty clear when you look at the advantages. Unlike pills or surgery, it's totally non-invasive. There are very few side effects. The little units are usually pretty simple to operate, which means people can often use them themselves right at home. And on top of all that, it's a pretty inexpensive way to manage pain.
Okay, everybody, listen up, because this is extremely important. TENS is not for everyone. Just like with any medical treatment, there are some critical safety rules. It should absolutely never be used by anyone with a pacemaker or placed over a cancerous tumor or on the front of your neck. It's also a no-go during the first trimester of pregnancy, on open wounds, or for people with epilepsy. And this isn't even the full list. It is absolutely crucial that you talk to a doctor or a physical therapist to find out if TENS is a safe and smart option for you. Seriously.
So, from that simple, instinctual act of just rubbing a sore spot, all the way to using targeted electrical currents to close neurological gates in our spine, we've seen how understanding our body's own wiring lets us take some control over the messages it sends. And it really leaves you with a pretty powerful question, doesn't it? As we get better and better at understanding and interacting with our own nervous system, could hacking our biology like this, on such a fundamental level, be the future of how we all manage pain? It's a pretty amazing thought.